Hey everyone, and welcome to another deep dive. Today we're going to be exploring the world of programming languages.
Oh, fascinating stuff.
It really is, yeah.
Yeah.
And our source material for this is a really great university lecture. We're hoping by the end of this deep dive.
You'll have a better understanding of how we actually communicate with computers.
Exactly. And how the software that kind of runs our world is built,
It is really amazing when you think about it, how without these programming languages, you wouldn't have the apps on your phone.
Or like any of the websites that you visit.
Or even just like the operating system on your computer, they just wouldn't exist.
Yeah, they just wouldn't exist. So let's just start with a real quick definition of software.
Okay.
What exactly are we talking about here when we say software?
Well, it's essentially a set of instructions, that tells a computer what to do. It's kind of the brains behind all the cool stuff that happens on our devices.
Got it. So is those big, complicated programs that we think of? Or is it like everything, even down to like a calculator app?
It's everything.
Oh, wow.
From a simple calculator app to like a massive air traffic control system,
Yeah. Yeah.
And there's two main types of software.
Okay.
So you have what's called system software, which is kind of the stuff that makes your computer run, like the operating system.
Right.
Think of as the foundation.
Gotcha.
And
Yeah.
then you have application software, which are programs that we use to do very specific things.
Got it. Okay. So is it kind of like system software is like the stage,
Yeah.
and then application software is the actors who are putting on the show?
I like that. That's a great way to put it.
Yeah.
Yeah, now the language that we use to write both of these types of software is what we call a programming language.
Okay, great. So that's what we're really here to explore today, is this idea of programming language. It's how we talk to computers, basically.
Exactly.
And I know that they've gone through some pretty major changes over the years, right? It's not like they've always been super easy to understand.
Oh, absolutely. They've evolved a lot. In the early days, it was almost like trying to talk to a computer in like its native tongue, which is binary code.
Right.
All ones and zeros. Like imagine trying to write an email using only ones and zeros.
Yeah, forget about it. I'll stick to pen and paper.
Right.
So how did we move beyond that?
Well, the first step up was something called assembly language.
Okay.
It was a little bit more human readable,
Okay.
It used like these short codes to represent machine instructions.
Right.
But it was still pretty clunky and very specific to like whatever hardware you were using.
Right. So not very user-friendly.
Not really, no. And then things got really interesting when the third generation of programming languages came along.
Okay.
This is when they introduced high-level languages. These are languages like C, Java, and Python. And they use syntax that's much closer to English, making them a little easier to learn and write.
Okay, got it.
And they're kind of the workhorses of modern software development.
So that's when things start to look more like, the code we see in movies, with words and symbols that actually make sense.
Exactly, yeah. But there's still a gap between these high-level languages and the binary code that the computers understand.
Right.
That's where compilers and interpreters come in.
Oh, yes.
Yeah.
Compilers and interpreters, those are two terms that I always get mixed up.
Right, yeah.
Can you help me out with that a little?
So think of a compiler,
Right.
a translator, someone who's taking like an entire book and translating it into a different language, but all at once.
Okay, so very efficient.
Very efficient. They convert the entire program into that machine code in one go, which is what makes them super fast.
But I guess if there's a mistake in the translation, it's a little harder to track down.
Yeah, that's a downside, yeah. An interpreter, on the other hand,
Okay.
it's more like a simultaneous interpreter, right?
Right, okay.
Who's translating and executing the code line by line.
Okay, got it.
This makes it easier to find and fix errors, but it is slower.
Right, so it's that trade-off, right?
It is, yeah.
Speed versus ease of debugging.
Exactly. And now, going beyond those third-generation languages,
Yeah.
things get even more abstract. We have fourth-generation languages. Those are designed for very specific tasks, like querying databases, right? Like having specialized tools for different jobs.
Right.
And then there's fifth-generation languages.
Oh, wow.
Which are all about making computers solve problems without explicit programming.
Oh, very interesting.
But that's a whole other deep dive.
That's another deep dive for another day.
Exactly.
But for now, let's stick with the third generation, just because it seems like that's kind of the most widely used, right?
Yeah, I would say so.
And to kind of really look at how these high-level languages work in practice, let's pick one
Okay.
to look at. How about Java?
Java's a great example.
Yeah.
It's versatile, it's powerful, it's used in a wide range of applications, from web development to mobile apps,
Okay.
all sorts of stuff.
So what makes it so special? Like, why is that one so popular, do you think?
Well, I think one reason is its interactivity.
Okay.
You remember those applets you used to see on websites back in the day?
Oh, yeah.
Like those little interactive elements, a lot of those were powered by Java.
Oh, right. Like the little things that made the web feel a bit more dynamic.
Exactly. Yeah.
So they were kind of a pioneer in that sense in bringing that to the web.
Yes, I think so. And it was also designed to be a lot simpler to use and learn than languages like C++.
Okay. Well, that's always a plus.
Yeah.
What else? What else about Java?
It's what we call object-oriented,
Okay.
which is a way of organizing code into these reusable components. Think of it like building with Legos,
Yeah.
You have these different pieces or objects that you can put together in all these different ways.
Okay, so you're creating building blocks of code that you can mix and match to make different things.
Yeah, exactly.
Okay.
And that makes it much easier to manage large, complex programs.
Okay, that makes sense.
Another thing about Java is that it emphasizes security.
Okay.
It uses this sandbox approach, which means that the Java programs run in this restricted environment
Right.
to prevent them from doing anything like harmful to your system.
So it's like a playground for the Java program to make sure it doesn't cause trouble elsewhere.
I like that. Yeah, and then finally, Java is also really great because it's very portable.
Okay.
So the idea is write once, run anywhere, meaning that in theory, a Java program should be able to run on any device that has a Java interpreter.
So it's like a universal language.
In a sense, yeah.
Oh, that's amazing. No more compatibility headaches.
That's the goal. But like any language,
Yeah.
there are always, little nuances and challenges.
Sure.
So in reality, there can be variations in how Java is implemented on different platforms. We call these dialects.
Oh, okay.
It's like having different accents in a spoken language.
Right, yeah.
You can generally understand each other.
Yeah, yeah.
But there might be like some regional variations that could trip you up.
Yeah. So even in the digital world, we can't escape the complexities of language, huh?
That's right. But despite all these nuances, it remains a very powerful and widely used language.
So fascinating. Now I have a feeling no programming language is perfect, right?
No, of course not. No.
What are some of the trade-offs or limitations with Java?
Well, one thing to keep in mind is that it can sometimes impact speed
Okay.
because of its reliance on an interpreter.
Right, because it's doing it line by line.
Exactly, and that can be slower than just compiling the whole program up front.
Right, so that trade-off between the ease of debugging and then the overall speed.
Exactly.
Got it, okay.
And then another thing to think about is security, right?
Right.
Java has all these security features, which are generally a good thing,
Yeah.
but sometimes developers find them to be a little too restrictive.
Okay.
So it's always a challenge trying to find the right balance between security and flexibility.
So it's kind of like having a really secure fortress.
Yeah. Like great for protection,
Right.
but maybe not so easy to, get in and out of quickly.
Yeah, great way to put it. And then, of course, as we mentioned earlier, there's the portability issue.
Right, with the dialects.
Exactly.
Yeah.
So while the intention is write once, run anywhere, making sure that your code works the same across different platforms sometimes requires a little extra work.
Yeah, so it's like having that universal travel adapter.
Mm-hmm.
That mostly works, but you might still need specific plugs for certain countries.
Right, exactly.
There you go. Never a dull moment in the world of tech.
Never.
So now that we've kind of gotten a taste of how one language works,
Yeah.
what are your thoughts about the evolution of programming languages overall? Like, how would you characterize it?
It's really interesting to see how it kind of mirrors the changes we've seen in technology in general.
Oh, interesting.
And the way that we use computers,
Yeah,
right?
yeah.
We've gone from these massive mainframes that took up entire rooms.
Yeah. To these tiny, powerful devices that we carry around with us everywhere.
Right, in our pockets.
So it makes sense that the languages we use to program them would also have to evolve.
Yeah, totally. So what were some of the specific challenges that programmers faced with those earlier languages? Like, what were they really trying to overcome?
Well, I think one of the biggest hurdles was just the sheer complexity and tediousness of it all.
Oh, I bet.
Imagine trying to write an entire program in binary,
Oh, my God.
or even using those shortcodes in assembly language. It was incredibly time-consuming and error-prone.
Yeah, I can imagine the headaches that caused.
Yeah,
Makes you appreciate the tools that we have today.
for sure, even with their quirks.
Exactly, yeah.
And then another major challenge was portability.
Okay,
Because those early languages were so closely tied to specific hardware.
right.
You couldn't just take a program that you wrote for one computer and run it on another one
Right.
without making major modifications.
So it's like those old VHS tapes where you needed the PL system for Europe and the NTSC system for the US.
Exactly. And that lack of portability was a real bottleneck, especially as the computer industry started to grow.
Right. It makes sense that things would have to move towards something more universal.
It did.
So what were some of the key innovations that helped us break free from these limitations and move towards those more human-friendly, high-level languages? Like, what were the big aha moments?
Well, one of the biggest breakthroughs was the development of compilers and interpreters.
Okay.
These tools acted as intermediaries between the human-readable code
Yeah.
and the machine code that the computers understand.
Right.
And this allowed programmers to start writing in a much more abstract way without having to worry about all the nitty-gritty details of those machine instructions.
So it's like having that really skilled translator that's bridging the gap between the way we think
Exactly.
and then that binary world of computers.
Exactly. And as compilers and interpreters got more sophisticated, they could handle more complex languages, which then paved the way for the languages we use today.
Wow, so it's like a co-evolution almost.
So it is.
The languages and the tools developing kind of alongside each other.
Right. Very much so. Another key innovation was the development of what you call object-oriented programming,
Okay.
which really took off in the 1980s. And this allowed programmers to model real-world entities as objects
Right.
that had data and behaviors.
So instead of just writing lines of code,
Yes.
you were creating these virtual representations of things,
Right.
like a car or a building
Yeah.
or even a person.
Exactly. And then these objects could interact with each other in
Okay.
ways that mirrored real-world relationships.
Got it.
And this made it much easier to design and build and even maintain complex software systems.
So it's like moving from, drawing blueprints on paper,
Yes.
to actually building with those virtual Lego bricks,
I love that.
where you can assemble these pre-built components in different ways to create all sorts of new things.
It's a great analogy. And object-oriented programming also introduced this concept of inheritance,
Okay.
which allowed programmers to create hierarchies of objects that share common characteristics.
Okay.
So you can build on existing code, which makes things much more efficient.
So could you create like a vehicle object?
Yeah?
And then you could have car, truck, motorcycle, and they would all kind of inherit those basic properties of the vehicle, but also have their unique traits.
Exactly. That's a great example.
Oh, cool.
And this made code reuse much easier, which is essential when you're dealing with those large software projects.
Right, because who wants to reinvent the wheel every time, right?
Exactly. And then along with those big shifts, there's also been this trend towards specialization.
Oh.
So as different domains of computing emerged, like web development, mobile apps, data science, all of these different things,
Yeah.
specialized languages were developed
Okay.
to address the needs of those different fields.
So it's like having the right tools in your toolbox.
Yeah.
You don't want to use a hammer to tighten a screw.
Right. You need the right tool for the job.
Exactly.
And this specialization allows programmers to really work more efficiently and effectively in their chosen domain.
Got it.
So you wouldn't use the same language to build a website that you would to program a robot, for example.
Right. Okay, so it's kind of like the Tower of Babel in a way, but like
Yeah.
in a good way.
Yeah.
This kind of multitude of languages, each with its own strengths and purpose.
Exactly.
So with all this specialization happening, like, what do you think is next for programming languages?
That's a great question.
Yeah.
Well, one major trend that we're seeing is this rise of what we call functional programming.
Okay.
And this approach can actually make code more predictable,
Okay.
easier to test, and less prone to those pesky bugs.
So it's all about writing code that is clean and reliable and does exactly what it's supposed to do.
Exactly. And it's becoming increasingly popular,
Okay.
especially in areas like data science and machine learning, where accuracy and reliability are really important.
Yeah, because when you're dealing with massive amounts of data,
Right.
you can't afford to have any errors slipping through.
Exactly. And another trend to watch is this increasing focus on concurrency and parallelism.
Okay, break that down for me.
Okay, so think about it like this. Instead of having one chef working in a kitchen,
Yeah.
you have a whole team of chefs all focusing on their specific task.
Okay.
This lets you prepare a meal a lot faster.
Right, got it. So it's about doing things faster and more efficiently.
Exactly. And languages like Go and Erlang,
Okay.
those are designed specifically to make it easier to write programs that can take advantage of this parallel processing.
So it's like the evolution of teamwork, but for computers.
Yes, I like that.
Pretty cool.
Yeah. But of course, with all these advancements, there are also new challenges that pop up.
Right.
One of the biggest is simply the increasing complexity of software systems.
Yeah.
As we rely more and more on software, the potential for errors and
Mhm.
security vulnerabilities.
Also grows.
Right, it's like building a skyscraper.
Yeah.
The taller it gets, the more careful you have to be about that foundation and that structure.
Exactly. And so programmers are always looking for new ways to design and build and test software
Yeah.
that is robust, reliable, and secure.
Which makes sense.
It does.
It's like this never-ending game of cat and mouse almost,
Right.
where the programmers are trying to build these more secure systems,
Yeah.
and then the hackers are trying to figure out how to exploit them.
Exactly. But I
Uh.
think it's that kind of back and forth that really drives innovation and pushes the boundaries of what we can do with software.
That's really cool. It's amazing to think how far we've come
It is.
from those days of punch cards and binary code.
I know. It's mind-blowing.
And it's not just about the technology, right?
You know.
There's also the human element.
Absolutely, yeah.
Yep.
To programming. And that brings up a really interesting question.
Yeah.
What are some of those personality traits or skills that you think make someone a great programmer? What do you think kind of sets them apart?
Yeah, it's more than just knowing the syntax.
Right. Exactly.
I think there's a certain mindset that goes along with it.
Yeah, for sure.
So I think so, yeah.
Yeah. So what would you say are some of those traits?
Well, if I had to pick one that really stands out, I think it would be curiosity.
Oh, okay.
You know, that unquenchable curiosity. Great programmers are always asking why and how.
Yeah.
They want to know how things work
Yeah.
at the deepest level.
So it's not just about like following instructions. It's about really trying to figure out the underlying principles behind the code.
Exactly. And that curiosity often extends, beyond programming.
Oh, interesting.
They might be interested in math, science, art, music,
Yeah.
anything that stimulates their minds
Right.
and helps them see connections.
So it's like having that multidisciplinary mind, being able to draw inspiration and insights from all these different places.
I think so. And another really crucial trait is a love of problem solving.
Yeah.
Great programmers, they love the challenge
Yeah.
of taking a complex problem, breaking it down into smaller parts, and then coming up with an elegant solution.
So they're the kind of people who really love those brain teasers and logic puzzles that would leave me just staring blankly.
Totally. They enjoy that process of untangling the knots
Yeah.
and getting to that aha moment when everything clicks into place.
It's like solving a mystery.
It is. It is. And speaking of mysteries, attention to detail is also really, really crucial.
Oh, yeah, for sure. Because one tiny mistake and
yeah.
the whole thing can go off the rails.
They're able to think very systematically and spot inconsistencies that other people might miss.
Right, because I imagine even like a missing semicolon can bring a whole program crashing down, right?
Oh, absolutely, yeah. And there's also the creative side of programming.
Oh, interesting.
It might seem counterintuitive. Yeah.
But writing elegant, efficient code,
Yeah.
it's a form of art.
Oh, wow. So it's kind of like, an architect designing a building.
Yes.
It needs to be functional, but it can also be beautiful.
Yeah.
And even inspiring in a way.
Exactly. There's an art to writing clean, well-structured code that is both functional and aesthetically pleasing. And that makes it easier for others to understand and work with,
Yeah.
which is super important.
Especially when you're working on those bigger projects.
Especially with big projects, yeah.
Because let's face it, software development is rarely a solo endeavor.
It's true.
It's all about teamwork, right?
Yeah, for sure. Great programmers are also great communicators and collaborators.
Okay.
They're able to explain their ideas really well, listen to feedback from others,
Right.
and work together to achieve that common goal.
So it's like being a good team player, really, in any field.
It really is.
Yeah, when to lead, when to follow, how to communicate effectively to
Exactly.
get the job done. Well, this has been an incredible deep dive. It has.
We've gone from the real nuts and bolts of how these programming languages work
Yeah.
to the bigger picture of how they've evolved
Right.
and how they continue to shape our world.
It is fascinating.
And it just goes to show how intertwined technology and human ingenuity really are.
I think so.
So who knows? Maybe this deep dive has inspired some of our listeners out there
I hope so.
to maybe pursue a passion in coding.
Yeah.
If you're feeling inspired, just remember that the world always needs more creative and talented programmers.
It does. It really does.
So don't be afraid to jump in, experiment, and most importantly, have fun with it.
Exactly. Have fun.
All right, until next time, keep coding, keep exploring, and keep on learning.